In this lesson, we are going to study the graphs of objects moving with uniform acceleration. When an object's velocity is increasing, its velocity is no longer constant or uniform. We say that the object is in acceleration. If the object increases its velocity by the same amount over each unit of time, it is said to be accelerating uniformly. Likewise, if the object decreases its velocity by the same amount over each unit of time, it is said to be decelerating uniformly. To illustrate this, let's look at this car that increases its velocity by 5 meters per second every second. It starts accelerating uniformly from rest, so at time t0, its velocity is 0. 1 second later, at time t1, its velocity has increased to 5 meters per second. Another second later, at time t2, its velocity is 10 meters per second. Another second later, at time t3, its velocity has reached 15 meters per second. The distance it travels every second increases as its velocity increases. So d1 is smaller than d2 and d2 is smaller than d3. It is traveling at increasing velocity, but the rate of increase in velocity is constant at 5 meters per second. So we say that its acceleration is constant or uniform at 5 meters per square second. Since we know that the car starts from rest and increases its velocity by 5 meters per second for every second, we can plot its velocity time graph. So from time t equals to 1 second, its velocity is 5 meters per second. And at time t equals to 2 seconds, its velocity is 10 meters per second, and so on. It is an upward sloping straight line. Now, how do we plot the displacement time graph? As we learned in previous lesson, that the area under the velocity time graph gives the distance traveled. Hence, when we calculate the area from time t equals 0 to time t equals 1 second, we will be able to plot the distance traveled or displacement for time t equals 1 second. So the area of this triangle is half times base of 1 second times height of 5 meters per second, which will give us 2.5 meters as the distance traveled. Then we can plot it on the displacement time graph. Take note that to plot its displacement for time t equals 2 seconds, it means to calculate the distance it has traveled from the starting point, and that means the total shaded area here, this big triangle here. And this is equals to half times base of 2 seconds times the height of 10 meters per second, and that gives us a distance or displacement of 10 meters. So we can plot that on the displacement time graph. Likewise, we can calculate the distance traveled under the whole graph to get the displacement at time t equals to 3 seconds. So the graph is a curve. If you recall in our previous lesson, the gradient of the displacement time graph gives the velocity of the object. In the case of an accelerating object, the displacement time graph is a curve. Hence, the gradient of its tangent at any point on the curve gives the instantaneous velocity of the object at that point of time. Now let's examine the velocity time graph. If we were to calculate the gradient of the straight line graph, we will have to take the change in y-axis, which is the change in velocity, divided by the change in x-axis, that is the time duration. However, we also know that the formula for acceleration is change in velocity divided by time taken, which is the gradient of the graph. To summarize, the gradient of the tangent to the displacement time graph gives the instantaneous velocity at a particular moment in time, whereas the gradient of the velocity time graph gives the acceleration. In addition, the area under the velocity time graph will give us the distance traveled by the object. Let's go back to our accelerating car. Let's say after it has traveled some time, it starts to reduce its speed. That is, it decelerates. Deceleration is also termed as negative acceleration. Assuming that the car decelerates constantly at -2 meters per square second, That is, it reduces its velocity by 2 meters per second every second. When we plot the displacement time graph, we get a curve, but it is a convex curve. The distance traveled every second reduces as it decreases its velocity. The velocity time graph is downward sloping with a negative gradient, that is a negative acceleration. Take note that negative acceleration means the speed is decreasing. It does not mean the object changed direction. Negative acceleration is also known as deceleration or retardation. Positive acceleration means the speed is increasing. So far, we have learned about uniform acceleration or deceleration. That is, the object increases or decreases its speed uniformly over equal interval of time. In our next lesson, we will cover how to solve questions when objects are not accelerating uniformly.